Tyler Union, a division of McWane, is a global leader in providing quality ductile iron fittings, flanges, municipal castings, and restraint technology for the waterworks industry. With a production range of 2 through 64 inches, Tyler Union delivers a comprehensive line of domestic and import product options. Our products are backed by a dedicated customer service team, and nationwide distribution ensures a streamlined experience for our customers. Today, more than ever, exciting things are happening as the company invests in new technology and drives continuous improvement. Led by the McWane Way and its guiding principles that drive our work, our team is committed to manufacturing and delivering life-sustaining water infrastructure across the country. Our process begins with receiving melt stock. All raw materials entering our foundry pass through a calibrated radiation detection system. Using recycled scrap iron to produce our castings, Tyler Union domestic fittings meet green building and LEED requirements. Tyler Union has two methods of melting this scrap to produce ductile iron. The first is the cupola melt center, which feeds our main foundry. The second is our induction melt operations, which feeds our large diameter foundry. In the cupola, ingredients are charged in specific amounts to comply with AWWA standards. We mix scrap iron, foundry coke, and alloys into a charge of metal. This is heated using heated air and oxygen to produce molten iron. The iron goes through a desulfurization process and is then treated in a transport ladle with magnesium and alloys to create ductile iron. Samples of each treated ladle are taken and transported to the iron testing lab. The samples are ground and burned, and a report showing the percentage of each element in the iron is reviewed to ensure quality specifications are met. In addition to these samples, a test bar is poured every 3 hours during production and is tested for tensile strength, yield strength, and elongation properties. Test bar results are stored for 7 years and can be accessed for a specific product to ensure traceability. Before this iron can be shaped, a pattern is needed. A pattern forms an impression in a sand mold that replicates the shape of the desired casting. Tyler Union has several thousand patterns on hand, enabling us to make a wide variety of SKUs. Accurate calibration of the patterns is essential to maintaining dimensional accuracy required by standards. A core is also needed for the casting process. Cores are made through processes that utilize sand mixed with resin to fill a core box. This creates a solidified shape. The core is placed inside the mold cavity formed by the pattern. When the iron is poured around it and solidifies, the core breaks down, creating the inside diameter of the product. At Tyler Union, an alternative method of mold and core making has been introduced. The company's 3D sand printer uses furan resin sand to create molds and cores through a layer-by-layer construction process. Both large and small shapes can even be produced in the same print run. This technology enables the company to better meet customer requests for low-volume items without traditional tooling. The molding process is where the core is placed in a mold and molten iron is poured through a gating system to form the castings. Tyler Union has two green sand mold lines, the DISA and George Fisher DISA, or GFD. The sand is produced in a muller, where it is mixed with water and foundry clay. This mixture is then transported to the molding machines. Our DISA molding line produces the highest volume of products, running over 300 cycles per hour. The DISA produces most of our 10-inch diameter and smaller castings. The mold is vertical, and a core mast uses vacuum pressure to hold the cores in place until inside the mold. Molds are filled with iron from a pressurized furnace using a stopper rod, and the furnace is continuously filled with iron from the cupola. After the castings have been poured, they cool and pass through a drum to break away loose sand. The sand is then recycled, and castings are passed through a shot blast machine for further cleaning. Our GFD molding line produces castings up to 24 inches in diameter. This line is a cope and drag flask line. These flasks help to hold the larger volume of iron in place and reduce the likelihood of iron running out of the mold. Similarly to the DISA, the castings are poured and proceed to a punch-out area and drum before being cleaned in one of 3 shot blast machines. The largest castings at Tyler Union are produced on 2 mold lines that use no-bake sand molding. This involves the use of a resin mixed with sand that starts to solidify upon exposure to air. The IMF molding line produces castings up to 48 inches in diameter. The process begins when a mold box is filled with resin-mixed sand. After filling, the box will set for 20 minutes before being rotated. The sand mold is then removed from the box, and the mold is inspected and painted with a core wash before setting the core in the mold. Castings are poured from ladles rather than from a furnace at the IMF. After pouring, castings cool before proceeding to shakeout and shot blast. The second no-bake molding line is Tyler Union's large diameter Foundry, or LDF, a 53,000 square foot facility producing some of the company's largest diameter products. Castings in the LDF are produced using an induction melt furnace rather than cupola. This energy-efficient melting process uses a water-cooled copper coil with alternating current to induce a magnetic field around the charge to be melted. This creates resistance, and energy is dissipated as heat to melt the recycled scrap. Before pouring, a large continuous sand mixer blends furan resin and a catalyst with sand. The mixer can output 30 to 60 tons of this sand per hour into mold flasks placed underneath. When flasks are filled, the sand is manually smoothed to ensure consistency, and the gating channels are created through which the molten ductile iron will travel. The core is then set in the mold, and a core wash is applied to ensure a good surface finish on the castings. The sand used is routinely tested for strength, pH, moisture, loss on ignition, and grain size distribution. When flasks are assembled, a ladle, charged with the correct amounts of magnesium and silicon, is placed underneath the induction furnace, and pouring occurs. The melted ductile iron is then poured from the ladle into the mold flasks to produce the castings. An iron chemistry coupon, as well as ductile iron tensile strength samples, are collected for quality assurance from the iron. A shakeout process is used to separate the sand from the casting. Castings then head to the shot blast. After all castings at Tyler Union are cleaned, they travel to receive grinding. All flashing and imperfections are removed using pneumatic grinders, ensuring a smooth and reliable finish on products. Mechanical joint and flange fittings are then gang drilled for bolt holes, and fittings can be tapped if requested by customer. Tyler Union has a large stable of cutting-edge machinery for facing, drilling, and tapping, including CNC multi-axis mills and CNC multi-axis turning machines, in addition to manual drilling and tapping. All Tyler Union flange fittings are faced per AWWA standards, and drilling is inspected to ensure bolt holes are drilled through. After fittings receive final finishing, they are cement lined in accordance with AWWA C104. The cement is mixed using clean potable water and sand that meets NSF and Safe Drinking Water Act requirements. The viscosity of the cement is tested routinely to ensure proper flowability and texture. This test is called a slump test. The cement is sprayed into the waterway of the casting using specialty equipment. Any raised areas of cement are smoothed by brushing, and any excess cement in the gasket area of the casting is removed. Fittings can also be ordered bare, where no internal lining is applied. Tyler Union offers a variety of coatings to meet various application demands. The most common coating applied is an asphalt coat, which is applied by either spray or dip tank. Other types of coatings applied to fittings include a selection of Tnemic or prime coatings, as well as zinc coat. Tyler Union fittings and other products such as flanges, valve boxes, lids, and restraints then make their way to inventory and are placed in designated sell locations. Several months of the more common or stock items are kept in inventory to meet customer needs. When orders are placed, product is picked from the yard and audited for accuracy before being placed on pallets and shrink wrapped for shipment. Tyler Union maintains a vast inventory to meet the ever-changing demands of our customers. Inventory is held not only at the point of manufacture in Anniston, Alabama, but also in distribution centers across the country, including Anniston, Alabama, Dallas, Texas, Chicago, Illinois, Vineland, New Jersey, Riverside, California, as well as from facilities in Seattle, Washington, and Orlando, Florida. With these locations, Tyler Union can reach almost all major markets across the country in a single day. Another example of our commitment to the highest level of customer service in the industry. To better meet the needs of our customers, we have inside sales representatives located across the country at call centers in Anniston, Alabama, Tyler, Texas, and Riverside, California. Our inside sales representatives are experienced and well-trained to support our customers throughout the purchasing and receiving process to ensure a satisfactory experience. Our commitment to quality and customer service is what has continued to make us a trusted name in the Waterworks industry. And with the most knowledgeable and experienced staff, we continue to be a leader in providing quality Waterworks products at competitive prices.